Good evening, everyone. Today we had the lecture, The Future of Renewable Energy, Flexible Solar Cells, and it is delivered by Dr. Lakshman Gowda. So to introduce Dr. Gowda, he is a Ramanujan Fellow and Technology Scientist at SENS at IISc Bangalore, and is also the CEO of ABX3PV Private Limited. And with a PhD in Physical Chemistry from Bar Island University, his research focuses on renewable energy, climate change mitigation, and green chemistry. And so over to you, Dr. Gowda, please.
Good evening, everyone, and I would like to thank to Science Gallery team members and also the management for giving the nice opportunity to talk to here. So, I'm Dr. Lakshman Gowda, Ramanujan Fellow and also research scientist at Nanoscience Department, and I also have co-founder of ABX3PV Private Limited. It's a startup company, also incubated in that IISc and Nanoscience Department. So our main work is focusing on that solar cells, and we also work with a flexible solar cell. So I'm going to give a talk on that the future of renewable energy, in flexible solar cells. This is also upcoming new technology. So the content is like this. So I have start with that renewable energy. And then I will next move on to that solar cells, what is the traditional solar cells, how it works. And then silicon solar cells, what we have already in the market, this solar cell I will explain. And then next I will come to the flexible solar cells. This is the future of the renewable energy technology, and it can rule us around the next 20 to 30 years in that market. And next I will give the brief introduction of what we are doing in that emerging perovskite solar cell. This also be one of the flexible solar cells, we will do it. And so what is driving that renewable energy in India? So you can see that like India's peak power demand over the past 5 years and the shortage. So what you see that with time from 2019 to 20 to 24, we see that there's a huge amount of, power demand will be very high, but production of the power will be limited. Resource of energy will be limited. So is that like this is the demand in the beginning and will be deficit shortage of this one. But again, it's trying to equilibrium 2022-23. Again, it will be rise. So this is the new report from that one of that government body, Indian government body. India needs to be clean energy game, must aim for 600 gigawatt by 2030. It's a huge. At present, we can't able to offer this, but we have to grow in a different way. And this also claiming the same. There's a statement from that renewable energy department in India. Like India requires like minimum at this moment we have a 500 gigawatt. No, we can able to offer 500 gigawatt until 2030, but still we need additional 10%. We can't able to offer it. So this is a major driving force in India. Okay, we can go into the renewable energy. So in the renewable energy shares, where we are, usually you can start with this is the total energy generated in India in 2024, usually. Like coal is the 77% it contributes for the energy. And the rest is renewable energy contribute only the 7%, 7 to 8%. That's a very small percentage. And the rest we have natural gas, crude oil and lignite. But most of them here, other than renewable energy, it is like not eco-friendly. We also have that carbon footprint in our renewable energy generation. So what? India is aiming for the sustainable technology in that energy resource. You see that like, okay, I will show that why we are going for that carbon neutral zero technology. Why? Because since 1752, you can see that until 2020 per year, atmospheric carbon dioxide in that it's growing very rapidly in such a way that like it's very difficult to even control. So all the growing countries also trying to come back with that neutral energy policy, but still there's requires a huge amount of time. You can see that. And United States and Japan, they're looking for that carbon zero policy, neutral zero, net zero countries like 2050. India is aiming for 2070. So that is still we have around 40 years to go ahead to have that for 0% carbon. So this is what Modi ji is aiming for. You can start with that. India will bring that non-fossil 500 gigawatt by 2030, and then we'll move on to that 50% by 2030, and we have that net zero. We will be able to achieve by around 2070. That was the Modi ji dream. So when we see that in energy sector, most of the carbon footprint is coming from that, 51 is coming from that by electricity and the heat. And the rest is the carbon footprint is coming from transportation, industry and others. Industry is the second. Highest is from the renewable. Highest is from that energy production. So this can be replaced with the renewable. We can able to achieve for the carbon neutrality here. So when we are talking about the renewable energy, that means that it should be environmental friendly technology, green and clean energy, and low or zero carbon footprint technology. That's we going for the green and renewable energy technology. We have solar energy, wind energy, geothermal, tidal energy, biomass energy, and there are few varieties. But in renewable energy must be sustainable, it is abundant and renewable. So that's why it could be, we will call it as a renewable energy technology that we are going for the carry forward. And nuclear is also, but it is a clean and green technology, but it has a limited applications. You can't afford a lot. So in the renewable energy, and like it is from the 2024 last year, and I took it from the MNRE source, and we see that in the renewable energy mix, you see that 54% is coming from that solar energy, and the rest is from wind energy, and we have a small hydropower and biomass and waste grid. So most of the things are solar power. So like this solar energy installation is growing in India, and the government is also investing and the supporting for that renewable energy technology in only for the solar and also wind also. So when you see that solar energy, when you look for the scope, what is the scope we have in India, like how much support we are getting? You see that 2014 to 15, we have only 3.7 gigawatt we have installed. And then solar cell installation in India is growing exponentially. Until now, 2023-24, we have installed almost 74.3 gigawatt solar panels all around India. And but still projected to be very high, but because of that production capacity and then demands, how much we're going to get, only we can able to install only 74.3 gigawatt. So when we see that production capacity in India, solar energy, in that traditional silicon solar cell technology, what we are using now, and we have that, you see that there is a module production capacity is different. Module is just that we will bring, India will bring the silicon solar cell, just assemble it in India, and that is called module production capacity. Cell production is that at least from that silicon ingot itself, we slice the silicon solar cell and make it into the solar panels. That cost a lot. That we don't have the technology until 2022. Then people are started making on it. So we have that. Still, we have to establish the between that cell production capacity, module making the production capacity. Then only in India, silicon solar cell manufacturing will be more feasible and affordable technology. But we have a lack of that instrumentation facilities and also that ingot scientific how to grow the ingot technology for silicon, and those are still we are lagging. So that's why we are still importing that silicon cell from that to China or other countries. So there are alternative technologies developing with that. So these are the few companies in India, like they are the leading one manufacturing the silicon solar cells: Adani, Tata Power, MV Solar, Vikram Solar, and Goldie Solar. They are the front end now in India, like making that number of in gigawatt production of solar panels. And yeah, when we say that solar technology, when we come to the in theory, we see that we have a total solar light is coming to the earth. Only the 20% is observed by our atmosphere, and rest 60% is earth surface, 50%. 30% will be reflected back. So this 50% is like we have it approximately 173 billion terawatt of solar energy equivalent to the 10,000 times the world total energy. So if we harvest all this energy, we can able to give that output of energy to that almost 10,000 years, 10,000 times the world energy requirement. What it does, the simple solar panels, it converts that solar light into electricity. That's the only few things requirement. So when we say that solar cells, so like it looks very panels to us. The ideally what it consists of, we have a semiconductor inside, that's a silicon, and light absorbing materials, and have a light absorption range, it's called band gap, light absorption coefficient, and electron transportation in the system. This is the spectrum of the solar cells, spectrum of that our visible light, what we see here. This is the UV light, this is the visible light, 500 to 700 nanometer, and then we have that wavelength of IR region that we won't see. So this is the region where our solar panel will absorb the light. And how it absorb? You can see that all the semiconductor has the band gap. This is where band gap it will absorb the light, and then it will generate the electricity. So that's what I said, light absorption and absorption coefficient, like how strong it will absorb, that is important. And then charge transportation. So once it absorbs, whatever electron generated here, it has to be transported to the out. So that's why like these are the few key factors solar cell material should have it, then we will use it in the solar cells. And so when we say that there are few generation of solar cells, we started with the first generation. What we see here is that monocrystalline and polycrystalline silicon solar cell that we already see in the traditional solar cell market, what we have. And second generation is started with that amorphous silicon and CIGS, that's a flexible solar cell, and started from here. And the third generation, it's coming of the emerging technology. We started with that CZTS, organic solar cell, perovskite solar cells, polymer solar cell, all are multi-purpose, all are flexible solar cell, also on the glass. We can able to do it on a rigid surface. And there are many quantum dot solar cells and nanocrystal solar cells also. The most recently, past 10 years, emerging technology consists of hybrid perovskite solar cell and tandem solar cell technology. It's a mixture of two solar cell technologies. These are the major emerging technology. This is where we can able to see that record efficiency chart. This is called the NREL chart. In America measures that all the solar cells and how much efficient it is, and it's reported and recorded. So you can see that this is the one starting from 1950, silicon solar cell started, and at the end it reaches, now silicon solar cell can give efficiency of 26%, and some of them have reached even 26, most of them are here only. And highest reported one is that around 47%, it's a multi-junction solar cells. They are highly expensive, use it for the satellite application. But for commercial applications, only until 30% is reported is the better one with the cost-effective method. And this is available online, usually that chart every year is updated. And so when I see the standard silicon solar cells, we see that solar panels will be like this. We don't know what is inside. Usually solar panels is encapsulated between that two encapsulated material, which is called EVA or other binder. And then it will be encapsulated, two terminal will be out, and that will use it in the real applications. What it's really look like, here silicon solar cells, we have that silicon, and then N-type and P-type contact, and two metal grade, on the one top electrode and bottom electrode. It could be silver and aluminum in the top. And this is the silicon vapor. So usually we buy it outside of India, or we will also manufacture it in India. So this is the silicon architecture. And then what exactly happen when shine the light? Usually you have a PN junction in the middle, and then you have P-type and N-type silicon vapors. And then when the light, it will absorb the light, holes, and it will generate that holes and electrons, and it will move in the opposite direction, the reverse bias mode. So then it will be collected. So either collection will be in the batteries or a grid, directly we will use it. This is how it will work, and in a band diagram it will be like this. You have a valence band and conduction band, and when the light will absorb the light, it will be excited, electron will be moving in one direction, holes will move in the opposite direction. That's how scientifically it will happen inside the solar cell. And Once we know it's working solar cell, but how we will know, how efficiently we will know it will work? We do that IV measurement. It's called current and the voltage measurement, and it will give that how much current the cell is giving, how much voltage the cell is giving. That's how we measure it. Under the light, under the dark, you will see that how much efficient solar cell. This is how we measure it. So when I come to the flexible solar cells, right now, until now, I told about what's the traditional solar cells, existing one, and silicon solar cells already manufactured in India and selling out. So this is the future technology where it's not commercially yet, but there are some. Only cadmium telluride is that flexible. It's existed, but it's very costly. So flexible solar cells usually has a few layers, usually N-type. It's a stack of multi-layers. Started with the substrate, which substrate we wanted to take, either glass or flexible PET sheet or PEN sheet or any metal sheet, flexible metal sheet. Usually started with that. And then you have two electrodes. One is that N-type electrode and P-type electrode. And there is an active layer. Either it could be polymer or any organic molecules. Any molecules we will use put inside. And then regular two electrodes will be there, top electrode and bottom electrode, and that's how solar cell work. This is the flexible solar cells. These are that few types of flexible solar cells are there in that, not in the market yet, but it is in the research final stage. And usually started with amorphous silicon. It is started 1970s, 1980s, but it has some limitations. Maximum efficiency we can go to 10%, and last year there is a breakthrough. This amorphous silicon can go to 24%. That's a new method they have proposed. And then we have that cadmium telluride. This is the inorganic again material with that this can give the flexibility to that solar cell, and 22% reported. And this is the company it's reported. Actually, it's one solar company. And CJT, SE, CJTS. These are all few materials we can make a flexible solar cell, and it's all inorganic material based flexible solar cell. And then we have that organic material based flexible solar cells. It started with the small molecules. It gives highest efficiency of around now is at 20%. And then we can also have the polymer based flexible solar cells. And then perovskite, that's the highest reported flexible solar cells until now. It is that that's where we are working on the flexible solar cell. That's what you see in the Science Gallery. And these are organic bake. And then next one is that it's a multi-junction. There are a few different light absorber solar cell will be combined together, and that can go up to 30-35% flexible solar cells. It's all together, two materials together. That's called organic, inorganic, or perovskite silicon. And there are few combination of solar cells will be sandwiched, and it can give that highest efficiency. And it's called multi-junction flexible solar cells. And yeah, but other than the CDT, still those are in that production line also. It's not marketing yet. And silicon is there, but not much applicable. And started with that in flexible solar cells, we say that amorphous silicon based flexible solar cells. Usually that these things are all bent in that flexible substrate like aluminum or some plexiglass usually use it. And that gives that bendability to that silicon. And so stack will be like this. You have metal, flexible metal, and then amorphous silicon, and some graphene oxide. Some transport layer will use it, and the TCO from the top. So that's what we are using. It's a transparent conducting oxide, because in the bottom we have aluminum plate, flexible plate, so that it won't work. So you have the substrate. It's like either plexiglass or transparent glass will use it. So that's how it's work, flexible solar cell. And amorphous solar cell mechanism will be the same as silicon, previously what I have said. And so it's a recent breakthrough that flexible solar cells of something around 2 inch or 3 inch they have made. And it's a flexible. So idea is that they don't use that any flexible metal sheet or plexiglass. So they started with that silicon vapor. Already we have rigid silicon solar cells. So they made it some treatment, and now it's flexible. So that silicon solar cell, that's the new breakthrough. That's highest efficiency reported is 24%, and this could be the next future. It will come soon, but still it's in that research stage also. So next one is that cadmium telluride based flexible solar cells. So as I said before, CATTEL has the most promising. It's already in the market also, production, but it's very expensive to buy it. And it started with that flexible glass substrate and then an ITO, transparent conducting oxide, and the light is passing through in the bottom side. And we have N-type material and P-type material. N-type is a cadmium sulfide, we usually use it, and then cadmium telluride usually. There is a light absorbing material, and then in the top electrode metal we have. So the light is passing through here, we have that. This gives that flexibility, but this can also done in that there is a glass called ultra thin and flexible glass. So this is this glass usually, now it's a new trend is coming. Previously it was in a different look. This can withstand high temperature. Cadmium tellurides require high temperature for the processing it, because it's processed by the vapor transport deposition method. It requires that transportation of cadmium telluride and deposition in another place, and then and as annealing step around 300 to 400 degree. Glass should withstand the temperature. That's why previous glass has a limitation. Now this is overcome, and people are using it flexible glass, very thin, ultra thin flexible glasses usually. And this is something around 22 to 23% modules, not the cell. I'm talking about the modules are available in the market. That's also called the Corning willow glass. People have used it, and this is the American-based company. I think now they have the production line in Chennai. They have started for this solar cell. And next comes with that organic flexible solar cells. Previously, those two silicon and that cadmium tellurides are inorganic based flexible solar cell. Now this is that organic based solar cell. Usually, inorganic solar cells started with that flexible glass or a PET sheet or PEN sheet, which is called as polyethylene terephthalate, and this polyethylene naphthalate, something they have used it. And this is bendable, stretchable, and even glass can also use it to flexible glass. And then started with that ITO. Usually we requires that transparent ITO. You can usually see it in that our phone also, mobile phone, touch screen. So that's where they have used. Similarly, we use that ITO here. And then there is a whole transport layer. Transport layer, we will use it either whole transport layer or electron transport layer. In the middle, we have used it. And then you have an organic material we have put inside. So that's the organic layer is that transport. It's the one, it absorbs the light, and then it generates that holes and electron pairs and transfer it to other. And you have a metal grid and encapsulation. All the organic solar cells should be encapsulated. I think most of the solar cells will come with encapsulations, or else it will be oxidized and the performance will be loose. So encapsulation is one of the major for that all the flexible solar cells. And you see that these are the examples of some organic molecules they have used, some bigger, some polymers. It will also come small molecules. It will absorb the light. Idea is that molecule will absorb the light and it will generate the holes and electron pairs. And if you see that mechanically in mechanism, it will be like this. You have a donor and acceptor material, and then you have an exciton generation, and then electron go one direction and holes will go to another direction. There are to the opposite side of anode and cathode, and this will be we call as a metal top electrode, metal bottom electrode. These two are terminals, and then electricity will be flowed outside. Electron will go through the circuit, and because of this PET and PEN sheet and plexiglass, we can able to do that long coating of that flexible solar cells. Highest reported efficiency for that organic flexible solar cell, something around 20%. That's the highest and reported. And this is in the production line, and I think it may be available in 1 to 2 years, this solar cells. Next comes with that perovskite flexible solar cell. This flexible solar cells is made up of a new active material called hybrid perovskite. This is a new trending material since almost from 10 years. People are investing a lot on this because easy to synthesize, easy to fabricate, and it can be done on meter scales. So this kind of a new material is hybrid perovskite, and it's a mixture of organic and inorganic part. Organic part is that you have some small molecules, and inorganic part is the lead iodide based material with that organic inside. And so the stack will remains the same, like as I said that organic solar cells. Here you started with that flexible substrate, whatever we want. There are three options. One is the PET, PEN or glass electrode. Then we have that electrode is that ITO electrode usually, and then we have ETL, electron transport layer, other whole transport layer. We can switch either ETL or HTL, and then light absorbing material. This is the perovskite is the light absorbing material, we have used it. And this perovskite will absorb almost visible light until to that mid-IR. So that has a very high efficiency solar cell at this moment, and so mechanism will be like this. The perovskite will absorb the light and transfer the electron to the ETL layer, and the hole will go to the hole transport layer, and the top electrode either will be gold or a carbon or any other ITO we can able to deposit on the top. Both could be ITO on the both side. This will called as a even bifacial solar cells and more efficient. And this one reported efficiency is something around 27%. Now it's reported recently for this kind of solar cell, and flexible solar cells especially, because this can be done on a glass also, sheet also on the flexibles. It is because whatever I have said before, all can be done on that rigid substrate, but there is an option, so you can also go for the flexible substrate. People will also go for the flexible. So this is the example of the perovskite already we have, and we also made some flexible solar cells that we have put it in that in the gallery. It's based on this material itself that we do in our lab. And yeah, then flexible solar cell, there will be two major testing will be confirmed. It has to pass through the test. One is that bending test, bending and stretching test. Why? Because that we bend a lot, stretch a lot. How much cycle it will stable? For how long we can able to stretch it and bend it, and that gives that how efficient this flexible solar cells. Usually we bend like 30 degree or 60 degree. We have bend it and stretch it. There is equipment. It will do it. The testing, because once it started to bend and everything, there is a discontinuity between the molecules, and then break will happen, and then charge will separate, and there will be a electrical breakdown will happen. So like it won't work at the long period. So there are flexibility for that organic molecules, and it will withstand those circumstances, and it will stable for a longer period. There are people until reported around 4,000, even 10,000 cycles also. So that is good enough to show up that solar cells will works better. There are some flexible solar cells have reached that much bendability test. And second one comes with that encapsulation and the stability. Encapsulation is a major important part in that solar industries. I think most of the solars, like either they have used a EVA or a frit-based sealing. Frit is that glass-to-glass sealing with a glass, or EVA is the polymer people have used it. It's a UV curable polymer. And because oxygen and water molecules will kill the solar cells almost like in a month or in a years. So to avoid that, people will go for the vacuum sealing encapsulation. This is the major technique we will use it. And then they do that rapid test. Rapid test means that like you usually put it in that this kind of encapsulated solar cell in a humidity chamber with a temperature. They will test it and do the IV measurement for 1,000 hours or 10,000 hours. Then you see that whether this efficiency is sustainable or it's a degrade with time. That way, that it will tell us about that how this solar cell will be encapsulated. There is something to be improved or something to be added, that will be decided. And what is the beauty of that flexible solar cells? We can do that roll-to-roll coating. There's a machine, it's running all the time, and this is like this is a roll. It can roll all the way. We have the belt of that substrate. Substrate means like starting with a glass or a PET sheet. We can roll on top of it. So here we can coat that material like one type of layer, another layer, third layer. It will go like this. So that is called the roll-to-roll coating technology. So with this, with optimized method, we can able to coat it on that even a meter scale or even few meters people will coat. The examples you could see that there is a uniform coating from all around. So this is easy to scale up the technology. Silicon is extremely difficult, requires something around even 1,000 crores or 800 crores requires for the silicon solar cell manufacturing, even though. But these things are maybe 100 to 200 crores could be achievable in this case. And usually you can see that roll to roll up one electrode, second electrode, perovskite material, another electrode and top. So there are all the electrodes can be done just coating by on coating. That's the simple way we could able to do this flexible solar cell method. Usually it has a syringe pump. It will inject the solution all the time, and temperature bed we can able to maintain it. And these are the modules. Usually that silicon is a different way of making the modules, and this is that when you come to that flexible solar cells or third generation solar cells, usually we have P1, P2, P3, something around, in a series integration of many modules will be done. So that's how it will work. This is the many modules like this. And so the applications, where exactly solar cell, these flexible solar cells can be used. One is that you could see here in the grid level, on the rooftop, everywhere we can able to use it. It's foldable and carry it anywhere. We can able to use it on the house. It can also implement on that cloth, and we can able to use it wherever we go. We can able to power the electronics because it's flexible. And EV vehicles, because lightweight. Another thing is it's beauty is lightweight and high power. So that's what we can able to use it in the car or a drone or rocket or satellite, anywhere we can able to use it. And these are some examples. And another thing is that the self-powered wearable sensors. This is very important. It will avoid the charging. So it's a very lightweight material. We can put it on our hand or gadget. It will power all the sensors what we use it on daily basis. Okay, this is all about that I have mentioned about the flexible solar cells, and everything. So I'm talking about that what we are doing in the emerging technology in our company. There is a startup company incubated in IISc Bangalore, and the company name is ABX3PV, and work with the perovskite material that I explained before. It has a stacks of few layers. You start with the glass, and then ETL, electron transport layer, hybrid perovskite new material, whole transport layer, and the top electrode. We have top to top electrodes, and we also make the panels out of it. And we are the few members of professors. We all together we have started that IISc Bangalore about that. This is making that solar cell company. And what are the problems we are looking into it? Like because now India has all the silicon solar cell technology, but still we need to come with a new technology that can fulfill that because we need energy demand is higher. So our is that carbon zero and net zero we wanted to complete. It's a 2030 that we wanted to have at least, as I said before, number. And the photovoltaic renewable energy technology that we wanted to go, and the silicon solar cells is the third generation. It's a low cost technology, but still India don't have the technology that silicon solar cell manufacturing. Equipment also we don't have it. It's a cost, and raw materials, everything it has to come from other countries. So manufacturing capacity also low. We can't able to reach that required volume of the electricity. And application, there are few applications are available for the silicon solar cell. It can't be applied everywhere. So whatever I have said previously, some of the technologies are not available in India. So only this perovskite is pitching up in that India, and it could be scalable very easily. And what is the important thing is that this is efficiency is higher than the silicon solar cells, whatever available in the market, in the traditional silicon. And it can also go for the tandem solar cell with the 35% efficiency with that hybrid perovskite. Cost is 3 times cheaper than the silicon solar cells, and it's a low cost and a scalable technology. And technology will be indigenously we can able to develop it. We have the technology and also raw material and the equipment able to make the manufacturing. This is available in India, and it can be integrated with the existing silicon solar cell technology. That's the new thing. So because as I said, perovskite can give 27% even maximum. But with the silicon, it can go 35%. Silicon solar cell industry is already established in India. So it can be added additives for that silicon, and also CIGS can be, any technology could be implemented with tandem technology. And good thing is it's a lightweight material and flexible. We can able to make the flexible solar cell with this material, and can be integrated with a drone or satellite, any application. It has other application also. Indoor PV and solar windows, as I said, that transparent solar cells and flexible solar cells. Another application is that we can use it in the indoor application. We can stick it anywhere. It can generate the power with a diffused light. It doesn't require 100% sunlight. Diffused light is good enough to power the small electronics. So that's why it will be useful for the indoor PV application. And windows, different colors of windows, we can able to make it. It still generates the power. And agrivoltaic, because agricultural, in some places that we have a lot of agricultural land, but we can use it also harvest the energy. So because this Hybrid perovskite, its absorption can be tunable. So I can have different colors so that it won't affect the growth of the agricultural whatever in the below, but still on the top it can able to generate that enough power. That's how it is a good application in the agriculture. And yeah, so what we do, this is in our lab, what we do is a flexible perovskite solar cells modules. We have make A4 size one, and this is still we are making, I mean, it's a production level, POC level now. And this is also flexible solar cells. We make the module like this, started with the small and it's a bigger one now. And application will be like this, so we wanted to go for that, making that production line, and also this technology can be implemented to that satellite and drone and IoTs and as a grid level. This is why the flexible solar has a very niche of applications. And as I said, yeah, these are the things we have started. Perovskite solar cell modules, we have it. As you see, that small lines are the each solar cells. This can produce like around 20 volt and something around 15 watt of power it can generate is flexible solar cells, and could be integrated with the tandem solar cells. And equipment, we can in India we can able to develop the equipment for this production of this one, and all the integration can be done, like powering the drones and IoTs and production line. And in our lab we started with that small cells, and then we reached around 18% for the A4 size modules. That's what we have. Yeah, and these are the people who are working in that, making the flexible solar cells in our lab. And our lab is located in that IISc Bangalore. Anyone can visit and check. And yes, when you say that market for that solar cells, emerging solar cells, what are the markets still available? PV has around 1.3 billion, and 2008 it can reach to 8 billion in India. And also drone, powering the drone with the solar cells, it can have the market of 0.1 billion. 28 it can go to 3 billion. IoTs for that, powering the IoT with the solar cell, it also market is growing 1.4 billion to 4.5 billion. Solar with that integration, its market is growing with that exponentially with the time, with the years. So you can see this. This is a market size, and also there are few players in India also. Oxford PV in Oxford, they are also making that perovskite solar cells, and flexible. Until now, flexible solar cells still in that experimental stage and not in the market yet. It's because encapsulations, bending testing, everything has to be performed. At least it should give it 5-year stability. Then only it can able to come to the market. So right now that flexible perovskite based flexible solar cells and can give around 5% stability, 5-year stability, and without flexible on a glass rigid substrate, it will give us a 10 years stability test already given. So perovskite based solar cell will almost next year or this year it will come to the market. That's available. And our idea is to go for our next year or 2 years from now, go for the production line for this flexible solar cell. And yeah, and this is the roadmap. We started with idea 2021, and then POC, proof of concept, started with that 24. Idea is that to have the production line 2026, and then licensing, and these are that one of the companies that we are working on, the ABX3 PV. That's the roadmap. And I would say thanks for the giving. Any questions you can ask.